So the leading coefficient test, remember that we're looking to see what the highest exponent is, right? So if it's AXN, if the n is even, so if it's a positive and it's even, they both point up. If it's a negative and even, if I could spell even, that would be helpful. Even, they both point down. If it's positive and odd, they fall left, rise right. And if it's negative and odd, they rise right and fall left. Okay, so, I mean, the good thing is, again, you kind of are still in that Corona cheat sheet stage. Even if you're physically in the building with me, if I'm allowing notes to happen at home, I'm going to allow the notes to happen in class, so you can kind of mentally prepare yourself for that. You would be able to have like some sort of a reference sheet. So in this case, this is the largest exponent is to the third. What? Okay. Is to the third, but the power, and then it's positive, which means this falls left and rises right. Okay, and then we'll get to the zeros, and we'll come back to this tomorrow. Just remind me we have to do 2 and 3 tomorrow. So yesterday we talked a little bit about what does a polynomial of higher degree look like. Remember, they're smooth, there's no breaks in them, no open dots. We talked about what does it look like to sketch a monomial. I know I'm going fast with this, but we did this yesterday, right? Yes, okay. We graphed these. We talked about the end behavior, which is what we just reviewed. And we left off here, zeros of a function. So in a polynomial function, the values of x for which f of x are equal to 0 are called zeros. Remember, the also can be called roots or solutions of a polynomial. Okay, we did this in, we did this obviously when we did the zeros from the last couple of sections. Each real root, because there could be imaginary, not so much today, but moving forward we're going to get into complex numbers. There could be imaginary roots. Each real root appears as an x-intercept of the graph. Again, something we already know, right? We did this with the last chapter. You list zeros, so we don't put them in coordinate point form. If my x values were -2 and 1, I would list them as -2 and 1, just like that. Anybody still copying that down? Good. Okay. So this says, find all the zeros of x to the third plus 2x squared minus 4x minus 8. So most of the time we'll be factoring to get these zeros. How do we factor when there's 4 terms?
Common denominator. I forgot.
Factor by grouping, right? We're going to group them. I know that's what you meant. So from the first set of parentheses, I could take out the x squared, and I get x plus 2. From the second set of parentheses, I would take out a -2, because I want my signs to change, or -4, sorry. And I get x plus 2. Now I take out what's inside the parentheses, because that's my greatest common factor, and then what's left over gets grouped together, x squared minus 4. Is that as factored as it gets? No, I've got the difference of 2 squares in that second set of parentheses. So I would factor that x plus 2, x plus 2, and x minus 2. So when we list the zeros, technically it's -2, -2 again, and +2. If I list the zeros, I only need to list the non-repeating ones. So my zeros are just -2 and 2. The number of times it occurs is important, and we're going to see that in a minute. But for right now, when we list zeros, that would be how we list them, okay? If this was an open-ended question, you would put them in order from least to greatest, just like that is. There's going to be all kinds of factoring, okay? So keep that in mind. This is, grouping. There could be trinomials. There could be all sorts of different stuff. Difference of 2 squares. All of it's going to get mixed in together. So this is why the number of times a root occurs is important. It's called the multiplicity of a root, okay? If a root occurs more than once, then the multiplicity is the number of times a root occurs. Again, if a root occurs more than once, the multiplicity is the number of times a root occurs. So if I see a root occur twice, the multiplicity is 2. If it happens 3 times, multiplicity is 3. If you only see it once, you don't really have to state it, but really the multiplicity is just 1. How that impacts the graph is as follows. If it occurs an even amount of times, it touches the x-axis and turns around at that point. Sometimes we call this bouncing. Actually, it bounces off the axis. So it's going to hit and turn around. If it occurs an odd amount of times, then it crosses through the axis. So if it starts above the x-axis, it continues through it. If it starts below the x-axis, it continues up through it.
All right, number 3.
Miss Chrysler,
Yep.
What we would want to do is 25 minus 11.
Go ahead.
Are you in Notability?
No, I'm in explain everything.
Oh, okay.
Why?
I was like, for highlighting, and like you couldn't say anything, and I was like, why isn't my why isn't my doing this? Okay.
There's a new highlighter. You know this? Max amount of turning points and -1. It is on yesterday's video though. Okay, so we're gonna put those things together. This says find the zeros, determine the multiplicity of each zero, determine the maximum number of points, a number of turning points, and then use a graphing utility to verify. So I already factored this, okay? We already solved this, and we got x plus 2, x plus 2, and x minus 1. X minus 2, right? So there was 2 -2's and a +2. We already factored this in an earlier example. Which means the multiplicity on -2 is 2. It happens twice. That's important, right? The multiplicity on +2 is just 1. You can put a 1, it's not wrong, but you don't need it. If there's no 1 there, it's implied that it's 1. So what does that mean about my graph? That means that it should bounce here and cross through here. Determine the maximum number of turning points. The highest exponent here is 3, which means max turning points is 2, n minus 1. Then I go to my graphing utility. So I'm going to go to the one on the app later. Okay, the 0, if I wanted to know where that actual 0 was, if it wasn't directly on the -2, it was kind of easy because it was directly on that -2 this time. But if I'm using a graphing calculator to graph this stuff, it may not fall exactly at -2. I go to that second calc menu. I click on 0 to find those zeros. The other way you can find a 0 is the table value. So this is my table value. They have to be whole numbers in order for you to see them this way. So keep that in mind, okay? And notice that there's 2 of them, one at -2 and one at +2 when you get to the table values. Just more practice with a graphing calculator. All right, so now we're going to put all that stuff together, okay? It's a lot of words, so I'm going to kind of like highlight the important stuff. First thing I do is figure out the end behavior using my leading coefficient test. Falls, left, right, rises, left, right, falls left, rises right, rises left, falls right. One of those 4 scenarios. Figure that out first, right? Then find your x-intercepts by setting it equal to 0. And identify your multiplicity. From there, you'll know if it touches and turns around, if it's even, or if it crosses through, if it's odd. Okay, the bigger the value of k, which is the number of times it occurs, the flatter it is around that. I very rarely use that, but that does help. It depends on how close it is to that root, but I very rarely use that, okay? The next thing I would find is the Y-intercept. Then I'm not going to ask you about symmetry. It's not going to say, is it symmetric? But certainly symmetry is going to help you determine how many points you're going to plug in. If it's symmetric to the y-axis, remember we plug in a -x. It goes back to the original. If it's symmetric to the origin, because these are functions, it's only going to be one of those. Then it would change everything. Okay, -x, -y. It's never going to be symmetric to the x-axis because it's a function, and that would fail your function test. So remember the same thing as even and odd. And then use the maximum number of turning points just to check. Okay, again, if I have a function that's x to the fourth and I have turned it 4 times, something's wrong with my graph. You run out of time?
She said it'll shut down in 9 minutes.
Hurry. He's taking a test. A math test. I was like, let me know if you don't know the answer. No, I'm just kidding. All right. Example 4 puts it all together.
For the dot day. I just wanted to post the one just.
So it says graph f of x equals x to the fourth minus 4x squared using what you've learned in this section. Start the same way and you'll always get a pattern. It will be easier, okay? First thing for me is always end behavior. So look at my function. Make sure it's in decreasing degree order because that's going to make your life easier, okay? It is, which means the highest exponent is 4. That's even. The sign on that term is positive. What's the end behavior if it's even and positive?
Both up.
Good. Both are up. It's going to rise left and right.
What's OFO?
What?
What's OFO? Hey, Oprah.
Both up. He's like, what's OFO? Okay. 2 is find your zeros. So I'm going to take this and set it equal to 0. X to the fourth minus 4x to the second equals 0. Factor out an x squared minus 4. Factor that, x plus 2, x minus 2. Then split them, set them equal to 0. Now when I square root 0, I get plus and minus 0. That's a plus and minus, which means there's 2 of them. They are obviously both plus. There's no such thing as a negative 0, but that means there's 2 zeros. Because I could split this and say x times x, and each of those are going to equal 0, right? So I have 0 with a multiplicity of 2. And then I have negative 2 with a multiplicity of 1, and I have positive 2 with a multiplicity of 1. Those are my zeros. If you were to list these, it would probably do it in order from least to greatest, but I think this question is multiple choice because I tried to figure out how to format with the multiplicity and it would be a nightmare. So I just did multiple choice. Except for the overall graphing question, which we'll talk about. 3, Y-intercepts. If I plug 0 in for x.
Mommy, you're dropping you it and please email it to me. Please email it to me. I need it desperately.
Okay, that has a, obviously already know that Y-intercept because we got it from our x value, but obviously it's not always going to be that way. Hang on, Jack. JP or Jack Patrick? No, JP. He has to submit his work just like we have to do it within the time allotted.
In 5 minutes.
He has 5 minutes to submit his work. All right. Now I want to plot what I've got. So I'm going to draw in the lines because they're hard to see here. Okay. I'm going to start by plotting my zeros. So I've got negative 2, 0, and positive 2. I know the arrows both go up.
How do you do this, Mommy? How do you turn this into a PDF?
You can't. That's what you needed to do?
Oh, print
Yeah.
and then turn it into a PDF.
Yeah. I appreciate you figuring out how to troubleshoot all by yourself. Good job. Okay, now I need to know, does it cross through at these points or does it bounce? Remember, it bounces if it's an even multiplicity. So this graph is coming down because it's crossing through it. It's coming back up and bouncing off the 0, coming back down and going back up again. Now, I don't know how far down it's going. It could do that. It could like this, right? I don't know how far down it's going. And that's one of the things I have to check. But if I know my symmetry, which if I plug in a negative x,
Yay! And now I'm going to get my other column.
it goes back to the original. I know this is symmetric to the y-axis. So everything that's happening on the right-hand side of my graph is going to happen on the left-hand side of my graph. You have to plug in additional points where you need them. So I need to know exactly how far that's supposed to go, which means I need you to plug in points in between. Now, knowing that it's symmetric means I really only have to plug in 1 point because it's going to be reflected on the other side. So I'm going to take and plug in 1. I'm going to do 1 to the 4th minus 4 times 1 squared. I get 1 minus 4, which is negative 3. So it's going to happen on the right. It's going to happen on the left because it's symmetric. And I know cross through, hit the 3, come back up, go back down to 3, come back up, and there's my graph. So you will get asked questions just on like find the zeros in the multiplicity, find the end behavior, and then you're going to get one big question like this that's going to ask you to graph it and give all those parts. That question is going to be like a take a picture and submit it. So it's going to be a handwritten question that you'll take a picture and you'll submit it. It was just way too hard to format any other way because the way you guys can write this stuff.
Like the one big graph we had on the last.
Except that that was all fill in the blank. And this is going to be a file upload.
Oh, okay.
Yeah, so it's going to, say that again?
What number are we looking at to know if it bounces or not?
How many times a root occurs? So the multiplicity. So because I got 2 zeros, the multiplicity on 0 is 2, right? I got 1 negative 1 and I got 1 positive 1. I mean 1 negative 2 and 1 positive 2.
And bounces are from the highest exponent, right?
No, bounces is the roots. So multiplicity comes from the roots. Bouncing comes from it. Turning points comes from the number. Yes. So there was a max amount of 3 turning points here, right? I came down, I went back up, that was 1. Up, came back down, that's 2. Down, came back up, that's 3.
Right, yeah.
Yep. All right, we're going to do another one. You ready? Isn't this so fun? All right. Start with end behavior. Look for the highest exponent. It's at the front. It's not always going to be at the front. That is now odd and positive. So what's my end behavior?
Down on the left, up to the right.
Good. Falls left, rises right. To B, we'll call it because that's what the test is going to say. It's going to say A, B, C. B is your zeros. So 0 equals x to the 3rd minus 9x squared. Take out an x squared this time, and I get x minus 9. Set them each equal to 0. There's 2 zeros again, and 1 positive 9. My y-intercept again is going to be 0, right? Y equals 0 squared, or 0 to the 3rd, minus 9 times 0 squared, which is 0. It won't always be 0, okay? Just because these two are. It's not always that way. Now I go to my graph. Plot my zeros. I only have 2 this time. Falls left, rises right. So far I've got all that. Bounces at the 0 means it bounces here, goes down somewhere, comes back up to hit the 9. Now I need a point in between the 0 and the 9 to see how low that dip goes, okay? This is not symmetric to the y-axis or to the origin. If I plug in a negative x here, it stays negative. Plug in a negative x here, it goes back positive. Remember, they all have to change or none at all. So I have to plug in a point. I want it to be midway through those. I don't want you to plug in like positive 1. That's not enough to get that full scoop. So I can plug in like 4 or 5. Let's plug in 4 to make our lives a little bit easier. So I'm going to plug in 4, and I would get 4 to the 3rd minus 9 times 4 to the 2nd. 64 minus 9 times 16. 64 minus 144 is a negative 80. Lord knows I don't need you to count down to negative 80. I just want you to drop it as far as you can, plot a point, and write what that coordinate point is. No, Chase. I don't need you to count to negative 80.
Why not?
You can do it for extra credit.
Did you hear him?
What?
He said you could do it for extra credit.
I'm already at -9.
He's going to keep going, Si. Thanks for that. All right. Questions on that one? So you will get a big graph like that. It's going to give you the function. It's going to ask you for the end behavior. It's going to ask you for the zeros with the multiplicity. And it's going to ask you for your y-intercept. And then it's going to ask you to graph it. Okay? That one you'll graph by hand. So you'll have to actually physically draw that on either a piece of paper or on Notability. And I'll give you the little graph. Okay? That kind of puts it all together. Questions before we move into that next? Yeah?
When you're plotting the additional points, you can pick 4 or 5.
Correct. Yeah. Like I don't want you to pick 4.5, but you could pick 4 or 5 because it's kind of in the middle. Yeah. You're welcome. So now we're going to do part 2. The good part is this is fast. This is the reverse. So this is what happens if I give you the zeros, you have to give me the equation. So if you can FOIL, you can survive this section. You just have to be really careful, okay? Because there's a lot of signs that sometimes get you. So I am going to give you the root. You are going to give me the function. To do that, you're going to write an equation as f of x equals x minus each of the numbers you get. So the minus will always change the sign. If I give you a positive, it's going to be obviously subtracting. If I give you a negative, it's going to change it to positive. Then you multiply out the polynomials, and that is your function. So we start with something like this. Find the polynomial function that has the given zeros. I'm going to do x minus a negative 1 becomes plus 1, x minus 3, and x minus 4. So it's always the opposite sign, because think about it, if we solve this, we switch the sign. Now I'm going to multiply these out 2 parentheses at a time, and it doesn't matter which order you go. So let's just say we multiply these 2 first. We want to FOIL that out. I'd get x squared minus 3x plus x minus 3. Combine that, x squared minus 2x minus 3. That gets multiplied by x minus 4. This is where mistakes are made, so be careful. I legit still draw my little scoops, even when I'm doing your keys. I would say x squared times x is x to the third. X squared times negative 4 is negative 4x squared. Go to the next one. Negative 2 times x, negative 2x squared. Negative 2x times negative 4 is positive 8x. Go to the last one. Negative 3 times x, negative 3 times negative 4. Combine your like terms. Set it equal to f of x. It's a function, so it gets an equation. You okay? Jack, you okay? Questions on that one? Ready for the last one? Okay. Same question, but obviously I've got some square roots here. I have to do x minus the whole expression. So x minus 3 plus root 2 and x minus 3 minus root 2. That negative changes the sign of both the things that follow. And again, I know you're smart. I know you can do things in your head, but that's also how smart people make mistakes. So be really careful here. I legit still draw it out. X times x, x squared. X times negative 3, negative 3x. X times root 2, positive root 2x. Go to the next one. Negative 3 times x, negative 3x. Negative 3 times negative 3, positive 9. Negative 3 times root 2, minus 3 root 2.
Chris Weiser, do you put the x inside the square root?
No, good question. So the x can actually be on the front or it can be at the end, but it can't be under the root. So be careful there. It's got to be after the square root. All right, last one. Negative root 2 and x, so minus root 2x. Negative root 2 and negative 3, positive 3 root 2. Negative root 2 and positive root 2 is negative 2 because square root 2 times square root 2 is just 2. All right, now I look through, combine my like terms. I've got x squared. Negative 3x and negative 3x is negative 6x. Positive root 2x and negative root 2x cancel out. 9 minus 2 plus 7. And negative 3 root 2 and positive 3 root 2 cancel out. If your initial square roots are opposites, meaning they have the same signs except for the one in the middle, the roots will always cancel out. So this would be f of x equals x squared minus 6x plus 7. Questions on anything we talked about today?
So all
If I don't have time. You're totally right. Okay, this one says find the polynomial function with leading coefficient 1 that has given zeros, multiplicities, and degree. So it says a 0 is 3 with a multiplicity of 1, a 0 is negative 2 with a multiplicity of 2, and the degree is 3. Pick that stuff apart, okay? What does leading coefficient 1 mean? Where's the leading coefficient go?
Parent function.
Okay, where's the leading coefficient go?
front.
At the front of the highest exponent. So when I write out my answer, this is telling me when I write my answer, whatever the highest exponent is, there shouldn't be anything in front of it. It should be a 1. That's what that piece of information is telling me, okay? Then it tells me that I have a 0 of 3 with a multiplicity of 1. What does that mean?
There's only one.
There's only 1 3, so I get x minus 3. How about at the negative 2 has a multiplicity of 2? What's that tell you?
It's x plus 2 twice.
Good. I get 2x plus 2's. And then the degree of 3 tells me the highest exponent on my answer should be 3. Those are just to check. So this and the leading coefficient thing are really just to tell you if you're doing it right. So now I got to multiply these out, okay? I can do it in any order, and this is a special product, so I'm going to start with that one. I'm going to do x squared plus 4x plus 4. Then I multiply that times x minus 3. And then do it again. X to the third. 4x squared. Positive 4x. Minus 3x squared. Minus 12x. Minus 12. Combine your like terms. Set it equal to f of x. Is my leading coefficient 1? Yes. Is my degree 3? Yes. So it's just a way of checking it to make sure you know what you're doing. Now we're done. Now any questions on 2-2?
I know in the homework I saw like a lot of fractions. Would that change anything?
So when you do a fraction, great question. Let's say it says 1/2, right? I can do x minus 1/2 or make your life easier. Bring the denominator over, and that's 2x minus 1. These are the same. So if you have a fraction, it's easier to bring the denominator to the front of the x. So if my root was like 2/3, I would make it 3x minus 2. Bring the denominator to the front. Ooh, geez Louise, where'd that go? Bring the denominator to the front. I don't know how I got that line there. Of your... So if it was this, I would bring this to the front. Okay, just gonna make your life easier. You'd get the same answer by multiplying out your fractions, but you shouldn't have fractions in your polynomial at the end. Now we good? Okay, so I'm going to